Jai Hind everyone, myself Sandeep Yadav, Assistant Professor CSC Department. Today I am going to deliver a lecture on Relational Algebra, which is a part of unit number 2nd of the subject DBMS being taught to B.Tech 5th semester student to CS, IT and allied branches being taught in AKTU. So the topic that I am going to deliver today is Relational Algebra. So this is the outline that I am going to discuss today. So I am going to discuss selection, projection, cross products, joins, operators, division, rename, aggregate functions. These are some of the topics within the relational algebra that I am going to discuss today. The first is relational algebra. So relational algebra is basically a collection of operations to manipulate relation. Actually, it is a procedural language which determines what data is required and how to obtain data. Now, the question before us is as to why to study relational algebra when we are already studying the SQL, which is a structured query language that is used to retrieve the data from the database. So, why we need relational algebra? See, the study of relational algebra is essential because for three fundamental reasons. First, it lays the formal foundation for the relational algebra. Second, some of its features are incorporated directly in the SQL. Third, it is used as the basis for optimizing and implementing the queries. So, first of all, we will be studying the operations in relational algebra. First operation is selection operation, which is denoted by the symbol sigma. This is the symbol sigma and notation is sigma. In subscript, we write the condition followed by the name of the relation. Now, this operation, what it performs is, it selects the certain tuples from the relation that satisfies a given condition. And the various operators that can be used are equal to, not equal to, less than equal to, greater than, and various logical operator and or not. Now, this operation, select operation, is used to retrieve the horizontal data, that is row wise data, that is we want to retrieve tuples based on the condition, that is this operation perform the horizontal partitioning of the relation, that is the horizontal partitioning in this way, not this one, that is vertical partitioning, this one is the horizontal partitioning. So, this operation basically perform the horizontal partitioning, right. Now, we want to find out the detail of the student who belong to the CE branch. This is our relation student consisting of 4 attributes along with the data. The attributes are the roll number, name, branch and SPI. So, what we want the detail of C branch. We want this and this row and this row. So, we have to find the this one and this one. So, how to obtain that? For that, we have to write the corresponding query in relational algebra specifying the condition that branch equal to CE. So, this is how we will be writing branch equal, we will be specifying condition here, branch is CE followed by the name of the relation, that the student. So, this will result in the following answer. 101 and 104 are the roll number, corresponding names and the branch. See, in the output we are seeing only 2 rows which satisfies the given condition. So, that is this operation divides our table into 2 parts, one which meets the condition and one which do not meet the condition, thereby performing the horizontal partitioning. Now, the question before us that arises, suppose I want to retrieve a particular name. Suppose we want to find out the name of the students in the table. So, this operation is not sufficient to find out the name of the students. So, we need certain operations which can find the data vertically also. For that, we will be needing certain another operation. Now, before proceeding further, I would like to throw some more examples before you. Display the detail of the student who belongs to either CE or ME branch. So, here we are having the two conditions, either the student is of CE or ME. So, here in the subsequent query, we will be writing sigma branch is CI or branch equal to ME, and this will be our output. So, we are seeing that this query will work in this way. So, this is OR. Now, suppose we want to find out the detail of the student whose SPI lies between 7 and 9. So, here the range is defined that SPI should be greater than 7 and SPI should be less than 9. So, this will give us this answer. Only there is one answer having SPI greater than 7 and less than 9, that is 8. This is how we are going to write the corresponding query. Now, the question that I was framing was how to find the data column wise. For that, we will be using the project operator that is denoted by pi. And this is the notation. Here we write the attribute list. There may be one attribute, two attribute, or n number of attribute followed by the name of the relation. This select the specified attribute of the relation. It also remove the duplicate tuples from the results. Now, let us discuss it. We want to find out the roll number, name and the branch of all the students. So, how to write it? So, we will be using the symbol pi. In the subscript, we will be writing the name of the attributes. So, pi, roll number, name, branch, and this is the name of the relation. And these are the attributes. So, the table will look like this. This is the roll number, name and the branch and the corresponding result. So, in this way we are able to find out the particular attributes based on the given query. So, clearly this operation is dividing our table vertically into two sets, one which fulfills our requirement and one which do not fulfill our requirement. Now, next question is display roll number, name and branch of ME branch students. So, these questions basically want to find out the attributes based on certain conditions. So, we have to find out the attributes, but we have to specify the condition also. So, this will be making use of both project operation as well as the select operation, but we must remember that we have to first use the project operation and thereby we have to use the selection operation. Let us see how to proceed with this. Step number 1. First, we specify what is the condition. The condition branch name equal to ME. So, this will be the first step. Thereafter, what we want to find out is roll number, name, branch This is the condition that is denoted by, this is the condition that branch name equal to ME, and thereafter is the name of the relation student, and these are the attributes that we need to find out. So, in this way we can make use of both of the operations to fetch the data. And if you want to write the select the query in SQL for this is select roll number, name, branch from student where, what the condition, where branch equal to ME. Now, one more question to make it more clear to you. Display the branch name, name of the student and SPI of the student where SPI is more than 8. So, here the condition is SPI has to be greater than 8 and the attributes are name, branch and SPI. So, let us see how to do this. Condition we are specifying now. Pi, name, branch and SPI. The condition is SPI should be greater than 8 and the name of relation is student. So, the output will be like this one. Of SPI greater than 8 is 9 and 9. So, this one and this one are already depicted in this our table. Now, what should be the final outcome? Name, branch and SPI. See, these are the attributes that we require at the last. So, earlier when we impose condition, it gives this one SPI for 8. Now, within this temporary, what we want to fetch is name, branch and SPI. So, roll number is not desired because it is not mentioned here. So, the output will consist name, branch and SPI on the basis of the attribute that are specified in the select list. So, that is the final answer. Now, some more complex query, display name, branch and SPI of student who belong to CE branch and SPI is more than 7. So, there are two conditions that branch should be CE and SPI should be greater than 7 and 3 attributes are required. So, let us see the step 1. First, we need to mention the condition. So, branch equal to CE and SPI is greater than 7, right. So, this is coming. Now, we are further finding these attributes. So, we will be writing the query pi, name, branch and SPI. Then the condition is being imposed through select statement, select operator, branch equal to CE and SPI greater than 7 followed by the name of the student. So, this is the answer. Next operation is cross product. Suppose cross product, as you know, is represented by the symbol cross. So, it shows all the possible number of combinations of table 1 and table 2, relation 1 or the relational 2 as it was done in previous years in mathematics. So, it will multiply each tuple of relation 1 to each tuple of relation 2. So the attributes of the resultant relation will be equal to the attribute of relation 1 plus the attribute of the relation 2, and tuples will be the of resultant relation will be equal to the tuples of relation 1 into the tuple of relation 2. Now we have to perform the cross product between the student and the results. So let us see how to perform. In this way we will write the statement. So first this row will do with this, thereafter this one cross product, thereafter second row will start with first row of this result and the last. So there will be total 4 rows of both tables of the resultant one and having the 5 attribute. One roll number is being fetched from both tables, which is being shown here. So if both the relation have some attribute with the same name, it can be distinguished by combining the relation name before the attribute name as shown here. This roll number belongs to the student, so append the table name before this roll number. Here also this roll number belongs to the result, so append the result before the roll number. Again we have to perform the cross product between student and the result. Consider only the following attributes that are shown above. This time we are not taking all the attributes, only the mentioned attributes. So this will be the output. Student, from the student roll number, name, branch, this roll number from the result, SPI, and this one. So 2 into 2, that is 4 tuples will be the output. As such, we are seeing that this operation is not highly successful unless until we specify the certain conditions, because we are not interested in all the combinations. We are interested in only certain combinations. So to make it meaningful, we must impose certain conditions on the Cartesian product. Next is inner join, which is denoted by this symbol. The notation is relation R1 join relation R2, or algebra 1 join algebra 2. If we want to fetch the data that is not present in single table, then we have to make use of join. Basically, join operation is used when the data is not present in single table. Instead, it is present in more than one table, maybe 2, 3, 4, and up to n table may be there. So there we have to fetch data from more than one table, then we have to make use of join operation. So join operation, natural join operation will retrieve the consistent data from multiple relations. It combines records from different relations that satisfy the conditions. So steps performed in natural join are: first is it performs the Cartesian product, then it removes the inconsistent tuples, then it removes an attribute from the duplicate attributes. Let us perform the natural join between the two tables, student and the result. This is how the join operation will be performed: student join result. So what will be the output? See, in order to have the join operation, one attribute is common in both the relation, that is roll number. So roll number will be mentioned only one: roll number, name, branch, and SPI that we are going to fetch. This 103 and 102 is not matching, so the output will be corresponding only to the matching values. Which values are matching? Which values of roll number are matching here? Only 101 is present in the both table. So output will be showing only the matching values. Unmatched values 102 is not present in result and 103 is not present in the student table. So these values will not be shown in the output relation. So this is the only value that will be shown. So see how sequentially it is done. First, the cross product is being done, right? Next step is remove the inconsistent tuple. So what are the inconsistent tuples? See here roll number is 10101, it is consistent. This is inconsistent, here roll number is 101 and here is 103. So this is inconsistent. 102, 101 it is inconsistent. 102, 103 it is inconsistent. So only the consistent tuple that remains is this one. Now there is a redundancy that roll number is being mentioned twice. So remove an attribute from the duplicates. So we will be removing roll number, one entry of the roll number, that is the final will be the roll number, name and the branch and the SPI. So roll number need to be mentioned only once. So duplicate entry of the roll number will be removed from the table. So as I was telling already also, to perform a natural join, there must be one common attribute or the column between the two relations. Now let us illustrate it further. So we have to perform the natural join between the two relation, branch and the faculty. So this is how the operation shall be performed. In both of the table, BID and BID are matching. So result will show all these things. BID is matching in both, so the outcome will be showing both BIDs of both tables. 1 and 2 are present in both branch as well as in the faculty. Next is outer join. See, natural join, we have seen that some of the record are missing. That is, suppose 101 is present in result table and not present in student table, and we also want to show that. For that, we can use the outer join. Now, outer join is of three types: left outer join, right outer join and full outer join. This is the notation: left outer join, right outer join and full outer join. To perform the outer join, one attribute must be common between two relations. Now, left outer join, how to perform? It displays all the tuples of the relation even though there is no matching tuple in the right relation. So it depicts all the tuples of the left relation even though there is no matching value in the right relation. So for all the such kind of tuples having no matching, the attribute of the right relation will be null in the resultant expression. Let us show. Perform the outer left join between the student and the result. So here we are seeing that this only 101 is common and we want to show 102 even though there is no corresponding match between in this one. So the left outer join will depict 102 also. So this is the output: roll number, name, branch and SPI. 101 Raj, C and SPI is 8. Now 102 Meet, ME branch. For this particular roll number, there is no corresponding entry in this table, the result table. So that value of SPI is being here null. So this is the left outer join. So clearly left outer join shows all the values of A and matching value of B. Now perform the left outer join between the student and the result. Only display the roll number, name and SPI. So what we want to display is roll number, name and SPI. This is how the query will work. Now right outer join. It will display all the relations of the right relation even though there is no matching relation in left table. Let us state with the example. See, here is 101 by 103, but 103 is not present here and we want to show this in 103 in output. Then we have to make use of right outer join. Let us see how this works. 101, Raj, C and 8 is the entry, 103. Now for this corresponding 103, there is no entry in this table. So these value will be null and the SPI will be 9. Now last is full outer join. It displays the tuple of both relations. It pads null value wherever it required. For such kind of values which have no matching, it will be padded with null. So it will be showing the missing values of left relation as well as the right relation. Let us see. Perform full outer join with the relation student and the results. This is 101 Raj. So it is showing the mismatch value of left as well as the right. So this is an example of a full outer join. So this completes our fundamental relations, some of the fundamental relations, relational operations of the relational algebra. I hope it is clear to you. Jai Hind.